Now, the point with when we're doing frequency diagrams, this data is continuous. There is no gap or no values which aren't being catered for between one group and another. That means that our bars can touch. When we've got discrete data, things like the number of marks in a test, strictly they should, if it's marks particularly, they should have a small gap because technically you can't have half marks, or if someone's allowing half marks, you wouldn't be allowed a quarter mark. I know that often doesn't happen when you see people do graphs, but it is what should happen. If you're doing the frequency of colours, yes, you can blend colours, but what says what order they should be blended in and put next to each other so that things can mix up. So they should have separate colours. What do you call red? What do you call yellow? If you're grouping things by colour, you're making definite decisions of that's red, that's yellow. You might say there's an orange in between, but you're making definite decisions about which colour is which. They're not being allowed to blend. So discrete data, you need to leave gaps between your columns and you label the middle. With this continuous data, we use the full width. So I'm going to draw in my graph using 0 to 1 is 6. Comes down. 1 to 1.5 is 3. So 1 to 1.5, notice that's 1.5, so it's narrower. 1.5 to 2 is 4. 2 to 2.5 is 3. 2.25 to 2.5 is 5. And 2.5 to 2.75 is 4. So we get another column like that.
So is this same as this, but different graph?
This is a different graph. It's the same data, but we're looking at a different way of measuring an average in it, or saying where the middle of my data is. Now, if you look at that, there's a little bit of a problem here that we've got this unfairness. This whole area represents 6 people. All of that area represents 6 people. The area here is representing 3 people. Now this area is a lot bigger than twice as big as the area of this smaller one. That's massively bigger. We've got loads more, which is showing that there's an unfair weighting in here. So this is an unfair group. So be able to say the mode here, that is misleading. This modal group is misleading. Now, what we're going to do is we're going to actually deal with that. And notice we were dealing with area. So it's the area of the graph that we need to consider as being what's the total amount. And that means that we're going to change how this all gets represented. You may have seen questions in the past where they were talking about why is this sort of graph about milk cartons misleading? And it's because they're using different width areas and they're saying there's 6 of this type of Guernsey cow and we've got 3 of this type of Jersey cow. And because the bottles are stretched in both directions, this is misleading. The same idea is here. This area is misleading about how important is that group. Okay? So the way we can deal with it is we now know we've got to deal with the area. So these two things together are going to make the area, and the area tells me the frequency. So I've got a group 0 to 1, I can say the width of that group is 0 to 1, so the width of that group is 1.0. Width of the second group, 1.5 to 1, is 0.5. Width of the third group is 0.5 again. Width of the fourth group is 0.25. Width of the fifth group, 0.25. And width of the sixth group is 0.25. Now, some exam questions do something a little bit different to this, and I'll dig one out as a sort of starter next week, just before we start doing things, because we've got a short week next week. We'll do a couple of exam questions on this stuff and do maybe a mini test. But tomorrow, remember, a mini test. So the area of this rectangle needs to represent the frequency of 6. What height would I need for that rectangle then?
6.
Okay, so that is area of 6 divided by 1, height must be 6. Area of the second group is 3, but its width is 0.5. What height does it need?
Also 6.
Yeah. Next one, we've got 4 and 0.5. Height would be 8. Oh, 8, not 8.8. 3 and 0.25, it's going to be 12. So what we're doing to find this thing is we are doing the frequency divided by the width of the group. That gives me the height of the box, which is called the frequency density. Frequency, because we're talking about height. Density, for how spread out should it be. How many people per square kilometre in a town. That's a population density. Same idea here, but we're now just talking about measuring compared to one value going across the bottom. Next one, my frequency density is 20. And the last one, my frequency density is 16. Now from that, you can probably tell me what's the most important group now. Go on, have a guess. Which is the most important group looking at this now? You can send in chats. Noah, Andre?
The fifth one?
The fifth one? Yeah, 2.25 to 2.5. This height makes it a lot more important. This is the equivalent of a mode, although they don't often deal with it as, say it's mode or modal group, but it's an equivalent thing. It is saying the most dense table, the most dense group is 2.25 to 2.5. And we can see that already. We'll have a look at it on the graph. So, the most dense group is 2.25, less than my height, less than 2.5. And that's very much analogous to the modal group. A few people yesterday, I was putting comments on saying, we haven't covered how to do modal group yet. So now I'm going to represent this on what's called a histogram. And the difference, Americans sort of gloss over these differences. They call these histograms as well. Strictly, they're not when you're plotting the frequency, although they're equivalent. But a proper histogram, the area is what your frequency is. So I need to do a set of axes that go from 0 to 3, and I need 20 up. So 5, 2, 4, 5. That's how big I need my axes. So I'm just going to move my bit of text over so it's out of the way. Just want to move the most dense group so I'm out of the way of my graph. Put in the values we've got. So we've got 0, 1.0, 2.0, 3.0, and this is the height of sunflowers. So I'm going to put title on here, sunflower, oh, better not put it there. And going up the side now, we are going to plot the frequency density. Freq density. And going up here, we've now got 2, 4, let's go 4, 8, 12, 16, and 20 is at the top there. Okay. Do the first group from 0 to 1. So we were still plotting using the same width, but now we're doing the height is 6. So that's my first group. That area is 6. Now, personally, if I'm doing frequency diagrams and I really want people to understand what's going on, I would actually put inside it how many people are in there. Actually, what is the frequency? It's handy when you do exams to be able to do that as well, because in an exam they often give you part of one of these graphs. So 1 to 1.5 again is 6. 1.5 to 2 is now 8. Two to 2.25 is 12. Uh, 2.25 to 2.5 is now 20. And 2.5 to 2.75 is now 16. And so now our histogram shows here is the densest group. We've got, for the amount of height, the number of sunflowers in that group is a lot higher than for others. And I'll just finish putting in the numbers. Like I said, this is not mandatory, the light blue bit. It's just a practice I do. Hang on. 6 times 1. Oh, sorry, that should be 3, shouldn't it? That's why. And if we look at the sizes of these things. So I've lost my pen, there we go. So there's 3, 4. That's a group of 3. That's a group of 5. And this group is 4. What we actually can work out from this is, looking at the group of 3, 2 squares is 1 sunflower. So 2 squares, if I create a little key, equals 1 sunflower. And then you can actually analyse the others. So there's 1, 2, 3, 4, 5 sunflowers. But now they're all, the area is representing the number of people, and it's representing it, the number of sunflowers. It represents it fairly, and therefore this dense group becomes more obvious. Does anybody know about what we often see if you look at heights of things? If you've got a lot of things which are supposed to be similar, anyone know what sort of graph you should get? So we were talking about heights of year 9 heights. Your height. Have you ever heard of a bell curve where there's some value in the middle and then it falls away either side?
Yes.
Yeah? You should see that with a lot of natural processes and lots of measurements of supposedly the same thing. And we've actually got the bell curve here in some way where it comes up to one value and then disappears. They can be skewed. This is a skewed one. But what we should find is the densest group. Well, technically a proper bell curve, it never quite goes down to 0. That's why you always see me leaving a gap. Although practically, when you have a limited number of people, it will actually cut down to 0 somewhere. And logically, it should cut down to 0. But this is actually a very advanced piece of science. You know, they found in 2012, they found the Higgs boson, and they were talking about the 5 sigma level. What they were saying was somewhere all the way out here, they've got a very small number of results that aren't saying it's the Higgs boson. And that's sort of one result in 2 million they were saying was not the Higgs boson. So that's what all of this links to, is actual measurements of values and be able to say, how sure are we that we've got the right sort of thing? So what we normally get is a section where this is the normal world. We've got some extremely small ones, we get some extremely large ones, but most things are in the middle somewhere. And this middle value, 2.25 to 2.5, actually starts agreeing a lot more with our mean. Where did I put the mean? Our mean was about just under 2. Our median was about 1.9, just under 2. And now our modal group is showing something similar. Our modal group is actually slightly higher, but if you think about the other two actually are balancing the number of things either side, which is why they're coming in here somewhere. But now our modal group agrees a lot closer than it would do if we just took that biggest value on the one side. All right, there you are. You've got 2 other ones to do the frequency curves and find the densest modal group. Okay, it's not a modal group, but it is the most dense group around of results.